Hello, and welcome to everyone. My name is Peter McCall. I work on policy and futures, and I'm a member of the Young Academy of Scotland, which is the early career element of the Royal Society of Edinburgh. Many of you will know the Royal Society of Edinburgh is Scotland's national academy. Our mission is to advance learning and to make knowledge useful. And this event is part of a series of new events around artificial intelligence called RSE Investigates AI. So I'd like to welcome you to the second talk of the series, which is with Professor Sethu Vijayakumar, who's a fellow of the Royal Society of Edinburgh and is also Professor of Robotics at the University of Edinburgh, the Director of the Edinburgh Centre for Robotics, and he's the Programme Director for AI at the Alan Turing Institute. And what he's going to be talking about today is from automation to autonomy, collaborative robots driving the future of work. So what's going to happen is Sethu's going to give us a 10-minute talk before leading us on to a live Q&A, which will last about 20 minutes. And if you wish to, you can submit your questions via the Q&A tab at the bottom of your screen at any time. The event will be recorded and also live streamed to YouTube. So Sethu, over to you.
Thank you, Peter. It's a huge honor and pleasure to be presenting here today. Let's hope technology works as it's supposed to. So what I will try and do is start sharing my screen. In a moment, you should be able to see this. Okay, my topic of today is from automation to autonomy, and I thought I would take a minute to just explain the title. So we've always thought about robots as things that are used to automate repetitive motions, things that we want to do again and again, build our cars of the future, etc. But what I want to think about robots, or what I want you to think about robots now, is more along the lines of a tool for the society, an active collaborative tool for enabling us to do things much more efficiently, do things that were previously impossible for us to do, and also do things that are dangerous and hard for humans to do. So really think about robots as going beyond pure automation, but as an interesting collaborative tool that would help you do things better, faster, more efficiently. So, and why do I say that? I say that because really, if you look across domains, we've started to see robots playing a significant part in traditional areas like manufacturing, things like assembly, but also in areas that are quite exotic. So space, underwater, robots for coral reef maintenance, also for things like enabling security of food supplies and dealing with the problems of the aged in terms of sustaining lifestyles well beyond certain ages in your homes, and things like autonomous driving and smart cities. So just to clarify, what do I mean by this concept of shared autonomy and collaborative robotics? So traditionally, we always thought about robots as repeating very faithfully the kind of things that we ask it to do. So that's what's on the left. Research in robotics has been trying to push this to scenarios where you are trying to get significant more autonomy in the picture. So really, I think the challenge in the next sort of 5 to 10 years is to think about what happens when we are in scenarios where sort of full autonomy is really not feasible yet, and maybe it's not what's desirable, and that's where I'm sort of talking about this concept of shared collaborative autonomy. So just to clarify, so why would you want to do things along the lines of collaborative shared autonomy? And the real reason is because we do want to look at some really scientific issues, scientific roadblocks for full autonomy. So for example, if you look at what we need to achieve in robotics to make a difference in some of the example scenarios that I have listed here, prosthetics and exoskeletons, self-driving cars, medical robotics, service robotics, industrial manufacturing settings. There are challenges due to close interaction with other objects and robots. There is noise in the system. The real world dynamics are really hard to model, and we have to have guarantees for safe operation. And when humans are involved, you have to be able to model and predict user intentions. So these are the scientific reasons why we want to look at collaborative shared systems. But actually, that is not the only reason. So you might ask, why do we want to use robots in the first instance at all for any of these applications? So there are some socioeconomic reasons for doing that. And they are kind of roughly in 3 or 4 different categories. One is to improve efficiency of man-machine teams, because as we have more population, we need to be able to meet the sustainably meet the industrial demands of tomorrow. We need to ensure food security for the next generation of people. Of course, there are scenarios or jobs that humans don't want to do, like hazardous asset inspection, repair and maintenance in our lots of different facilities that we have. And finally, we also have to think about the healthcare and aging society. How can we live independently much further down our age without having to move to care homes or hospitals? And particularly poignant right now is flexible redeployment in scenarios like emerging out of a pandemic like we are facing today. So things like low-touch economy, social distancing, co-work, these are things where robotics can play a big role. So let me slightly change gears and talk from the perspective of a scientist who is doing work in robotics. So if I think about what are the key advances in robotics, in machine learning technologies that have enabled us to realize some of these dreams, or are in the process of enabling us to realize these dreams, it falls under categories like perception, adaptive planning for dealing with dynamic situation, safe actuation, creating robots that are inherently safe. But the key aim is going back to my initial point of being able to seamlessly shift between different levels of assisted teleoperation and autonomous behavior, depending upon the demands of the task. So let me give you a very quick example. So the example, what you'll see here is a video where on the left is a robot doing some operations of picking something up, navigating through clutter, and then dropping it into another place. And on the right is a user console that a person is using to manage that robot in a different room. It could be in a different town, it could be on a different planet. And the challenges and really the scientific advances are that you can see that it is being able to build a map of the environment, of the world in real time, make significant decisions on its own in terms of avoiding obstacles, deciding which arm to use to pick up which object. But a human is controlling that at a higher level in terms of saying, I want you to pick this up and put it there. So there is a level of punctuated autonomy that can deal with delays, that can deal with user intentions explicitly, while the robot is able to make local decisions, safety decisions, things like an efficient way of doing things really very, very efficiently. So this notion of working in this shared collaborative fashion is not new. I mean, if you watch the Iron Man movie, sort of Iron Man interacting with Jarvis as a system. So when I talk about the science, and if you looked at the video early in the previous slide, this vision is not that much utopian anymore. But I want to finish by really giving you the scientific perspective. So what I've talked about so far, I mean, people who have a vision about using robots and technology can tell you about this. So there is very little debate about that. but really, what are the underlying open scientific questions or problems that we need to address and solve in order to deal with this efficiently? So this is what I want to spend my last couple of minutes on. So the first one is safe actuation. So we have to have inherently safe robots that are out in the field because of close interactions. So we can do this in two ways. One, by creating software which is able to adapt in real time to novel and changing conditions. So model predictive control with learned dynamics is the technical term for being able to do that. The second one is obviously being able to, in hardware, create inherently safe robotic platforms. So examples of that include things like compliant actuations with built-in springs, so that even if something fails, it is inherently soft and less destructive in interaction with people. The second biggest challenge is what I call reducing the sim to real gap for realistic training and testing. And this also can be called digital twins. So creating efficient digital twins. And why is this important? It's important because of cost factors. Not every researcher, not every person can access some of these robots because of both technological limitations and cost. But having realistic digital twins will allow us to test, train, democratize the use of some of these technologies to the extent that we can test these things for safety and edge cases much before we deploy it in the real world. And finally, I think this is very, very important, is about thinking about verifiable and explainable methods. So we are very good as scientists in trying to push the good things and the novel things that we can do. Similarly, journalists are very upbeat about technologies that can change the world. But I think one of the other responsibilities that we have to take very seriously as scientists towards the public is about not just explaining what the robots and technology can do, but also explaining very clearly the limitations and the vulnerabilities of the deployed systems. So that is where verification, explainable methods that can understand what happens when something goes wrong, we can effectively try and manage those risks in a way that is safe and easy to use going forward. So I think that is my 10 minutes that I wanted to talk to you guys about. And I'm really looking forward to a vibrant discussion, some Q&A on what are your experiences working with technologies like this, or what are your concerns that we should try and address. So over to you, Peter, for the Q&A session. And thank you very much to Royal Society for enabling this, and to Hannah in particular for organizing and setting up this wonderful opportunity for us to interact.
Thank you so much. That was, I think, a real tour de force. Just as a reminder to participants, you can add a Q&A, or you can add a question. We'll do the answers at any time as we discuss this going forward. So the first question I wanted to ask was from Paul Bentley, and he asks, how can AI be used in vaccine development? Is it being used for COVID-19 vaccine development? Maybe less a robotics question, more a broader question about AI.
So I see AI and robotics, there are two elements to it. One is the kind of data processing side of things. How can we efficiently, very quickly process some information in parallel to do testing and drug development, things like running through protocols for testing are things that can be done in parallel, and AI is helping us do this very efficiently. So I always tell my students, so sometimes there are some capabilities that are already superhuman. For example, some machine learning technologies and AI can detect patterns in scenarios that is not visible to the naked eye. And I think there is a huge potential for drug discovery, vaccine testing with machine learning in those settings. So I think there's definitely already software engineering that is enabling us to test this much more efficiently than we would have done in labs ordinarily. On the more physical side of things, I think already robotics is playing a part in automated sort of clean room testing, so that we can do this much more efficiently, much more sort of rigorously, so that the mistakes that a human technician may make may not happen, and we can document things much more efficiently. So those are the two kind of areas I see where in the development of vaccines and COVID responses, robotics and AI can play a big role.
Thanks, that's really clear. One of my real interests is in what kind of skills will be needed in order for us to live in a world with much more AI and much more robotics. So there's one of the questions that came in before the event was, what are the skills needed in future regarding robotics and AI in order to stay competitive in the labor market?
So that's a very, very important question, not just for you and me, but for the government and the countries to ponder very, very deeply. Because one of the things I kept or keep getting asked is, what is the effect of the current job market? What do the technology and robotics, how do they play a role in sort of changing the demographics of the job market? And so my honest opinion about that is we are going to use robots as tools to address some of the challenges that we are currently facing. But it also means that the actual job of what a human will be needed to do, things like monitoring some of these technologies and robotic hardware platforms, running tests and developing code to be able to do sophisticated tracking of bugs and errors, building systems that are inherently verifiable and safe. So those are the skill sets that we are going to require both in the near term and going forward. So we have to think very carefully about the demographics of the skill sets that we need to equip our next generation with. There is an immediate issue of how do we equitably sort of distribute the benefits and the wealth to this during this transition period, because this is not a short-term problem or an issue. It is thinking about the next generation. What are the skill sets that are required for the next generation? But there's also a long-term issue about thinking about what will the effects of technology have in our lives in 5 years, 10 years down the line, and what are the skill sets we require for addressing that. So software engineering, hardware, and things like design, manufacturing for the right form factor, and perhaps even things that we haven't even thought about, certain kinds of material and hybrid sort of biomaterials for interfacing with humans. So those are the things that come to me off the top of my head. Yeah.
Okay, and to take it on to a very practical question that I think many of us think about quite a lot. This is from Professor John Gillies at the Autonomy Institute. What do you think is the potential of robotics in the day-to-day care of frail elderly people?
So I think we have to be very careful in addressing the challenges, and we have to be very careful of the sector that we are dealing with, because there are subtleties in terms of different sectors. What we need to be very, very often careful about is changes depending upon the sector we are dealing with. So in particular, in the case of the elderly and dealing with things like assisted living in care homes, or indeed the future homes where which is sort of has a lot of technology built in. So one of the things we need to be careful about is the security. What I mean by security is data privacy. How do we get the best of the technology through while ensuring security of personal data? So what we call federated learning algorithms. So that is one big area of work. The second aspect of physically helping patients or the elderly to do things like preventive care. So to prevent falls to prevent some kind of issues with not being able to, not taking medicines on a regular basis. So there are technologies which can be used in a sort of preventive fashion. So both vision technology as well as predictive algorithms can tell based on how people move in the homes whether they are potentially likely to fall sick or have a danger of a fall in the next week or 10 days, so that we can do preventive. But there's a big role for robotics to play in also care post injury or post trauma. So exoskeletons, we even in our lab we test a lot of prototype exoskeletons for all the way from things like stroke patients to amputees. There's also work that we've been doing with many companies in Japan, in Korea, in the US on furniture that is inherently a robot. So things like beds which adapt from being a bed to a chair to things that can take you to do your everyday things like taking you to the kitchen or taking you to the bathroom without the external help of another person. So I think there are tools that can be customized and built around this, but we need to understand the biggest needs of the particular community, particular sector before we kind of say that this is a robotic solution to that.
Thanks. That's really interesting, and it's an area of real interest to me. We've had a couple of questions around this topic, so I'm going to pick on Nicholas Chagika's question, which is: has machine learning replaced classical control methods in robotics research, for example, reinforcement learning?
So I think this is a question that we, as researchers, as active machine learning and robotics researchers, tackle on a day-to-day basis in my lab meetings. So we have this very interesting debate. So my view on the things is that this is a fluid situation. So, and this goes back to the last point I made in my last slide about verifiability and explainability of situations. So deep learning methods, methods that are driven by purely data-driven sort of techniques, have actually shown tremendous promise in identifying patterns, solving problems that were hitherto sort of quite computationally hard to do. We've had very good examples of from gaming, so the kind of chess to the Go to novel sort of pattern recognition in autonomous driving. So I think there is tremendous advantage and benefit in acknowledging that these are very powerful techniques, and that's why I said there are some aspects of machine learning that are already superhuman, and it would be foolhardy not to take advantage of that. But at the same time, we have to kind of pull back and think about novel techniques within that framework of machine learning and deep learning, which can explain the reasons for particular decisions. When something goes wrong, can we trace the causal reasoning, what we call generative models, for the failure? Can we ensure that such failures do not recur under similar conditions? There's also a big debate about things like bias in such scenarios in machine learning techniques. So there's been recently a lot of debate about, does the bias come from the data that you feed a machine learning setting, or is it inherently there in the structure of the algorithm, or is there some other aspects to it? So those questions are equally applicable to adaptive control and learning in robotics. So what has changed in the 10 to 15 years that I have been kind of actively doing robotics is 15 years ago, we had very good concepts. We didn't have the compute power to deal with it. Now we have tremendous compute power. And so we are trying to find this right balance between, putting in physics and the knowledge, prior knowledge and the bias that we have, and then letting the compute power deal with some of the other issues that we cannot hand tune or hand engineer.
Thanks. I think that's really interesting. We've had, again, a cluster of questions around the education system, whether our universities are teaching the right courses, what we need to do to adapt to AI and robotics in an educational setting. And I'd just like you to respond to that. I think not just in universities or colleges, but all the way through the education system. What is it that we need to be doing to stay ahead of the curve on robotics and AI?
Yeah, that is indeed a question that I think many people are getting their heads around right now. And so the one thing, one nugget I can say, I'm not an expert in this area, but one nugget I can sort of say is that robotics and AI are built out of inherently interdisciplinary approaches. So the strengths come from the fact that you understand some of the core socioeconomic problems. You have some good grasp of efficient machines. So this is the mechanical engineering and the hardware side of things. You need to have a very good grasp of software engineering to kind of efficiently write code that doesn't break, that is inherently safe and bug-free. But there's also many other aspects, like, for example, the communication between devices. We have to build architectures that are secure, safe, and we have to worry about crypto hacking. So there's a big area of security that comes into the picture. So on top of that, there's a big role for social engineers to play here, because you have to understand the balance of needs in the society before we push technology down somebody's throat, so to say. So I think my sort of one nugget is, and this is not just sort of saying that informatics in Edinburgh is a good example of doing that, but it is indeed the case that when we bring together disciplines like artificial intelligence, computer science, social sciences, cognitive science, music, design, it creates a unique atmosphere where people can debate and sort of exchange ideas that a particular way of thinking would not have explored. So if I were to point out one particular nugget for education and skill set, I would say think about scenarios where cross-disciplinarity is encouraged and is exploited.
Thanks. Unfortunately, I think that's all we've got time for, although I think Sethu has agreed to sketch you an answer if you've submitted a question. So you will get something back if you've gone to the trouble of asking something. I personally, I'm really interested in the collective intelligence approaches that AI and robotics allow human society to focus on different questions, and very often higher level questions than the ones that we focus on at the moment. And I think it's been really clear from your talk that there's a role for all of us in that, and that the participation in the systems is really, really important. So I'm sure everyone who's participated will want to join me thanking Sethu, and also thanking the RSE for organising and hosting this. Hannah has been fantastic in pulling together the event. So thanks to Sethu, thanks to the RSE, and thanks to you all for attending. There'll be some feedback. There'll be a feedback survey for you at the end, and we hope you'll be able to join us for the rest of the series. Thank you.
And thank you, Peter, for hosting this wonderful session.